All right, now we're just going to go back to these original definitions to define what is the Pythagorean identities. So Pythagorean identities comes from Pythagoras' theorem based on that little right triangle, which is x squared plus y squared equals r squared. And then we're just going to see what happens if we divide all three of these by r squared. So I'm going to have x squared divided by r squared, y squared divided by r squared, and r squared divided by r squared. X squared over r squared is the same as x over r all squared plus y squared over r squared is the same as y over r all squared, and r squared over r squared is just 1. X over r is cos, so x over r squared is cos squared, plus y over r squared is sine squared, and then equals 1. So this is the first Pythagorean identity, but usually we write it in a different order. Usually we write it as sine squared plus cos squared equals 1, and that's the first formula you'll have on your formula sheet. Now what we're going to do is we're going to try to derive the other Pythagorean identities from this one. So sine squared plus cos squared equals 1. We're just going to take turns and we'll divide everything by sine squared this time. And then next time we'll divide everything by cos squared and we'll get two different new identities. Okay, so dividing each term by sine squared, I get sine squared over sine squared plus cos squared over sine squared equals 1 over sine squared. Well, this is the same as sine squared divided by sine squared is 1 plus cos over sine all squared, so it's cos theta over sine theta all squared, equals 1 over sine theta all squared, since 1 squared is also just 1. So then this is the same. I know that cos over sine is really cotangent theta, so cos over sine squared is cotangent squared. 1 over sine is cosecant, so 1 over sine squared is cosecant squared, and there is our second Pythagorean identity. Now to find the third Pythagorean identity, start again with sine squared plus cos squared equals 1, but this time we'll divide everything by cosine squared. So it's going to be sine squared divided by cosine squared plus cos squared divided by cosine squared equals 1 over cos squared. Sine squared over cos squared is just sine theta divided by cos theta all squared plus cos squared divided by cos squared is 1 equals 1 over cos theta all squared, again because 1 squared is 1 and cos squared is cos squared. Sine over cos is tan, so sine over cos squared is tan squared plus 1 equals 1 over cos squared is secant squared. So there is the third Pythagorean identity. Usually we write it in the other order though, as 1 plus tan squared equals secant squared. But those three are all given to you on the formula sheet. What you need to know, though, is that you don't just use them in this form. You're allowed to manipulate them. So for that first one, say you just subtract cos squared from both sides, then you get sine squared equals 1 minus cos squared. For the sine squared plus cos squared equals 1, if you subtract sine squared to the other side, you get cos squared equals 1 minus sine squared. So what I'm going to do here is just writing down all these different manipulations of these three Pythagorean identities just by adding or subtracting something over to the other side. You don't have to show this work of manipulating. It's just expected that if you see a secant squared minus tan squared, you just know it equals 1.